All right, for lesson 32, we're going to look at the math behind circular motion. Now, we're going to kind of focus first on the three main things that we've looked at before. So things like velocity, acceleration, and then force. Now, the first one, v is equal to d over t, is pretty straightforward, right? Velocity is equal to displacement over time. We've done that before. With circular motion, things traveling in a circular path, that particular displacement is a specific mathematical formula, the circumference, which is 2 pi r. Or pi d if you choose to use that. So basically v is equal to that substituted in 2 pi r over t. And that's it basically. There is one other variation of that, which is down here, because we introduced a new vocabulary term in lesson 31, which is period. Capital letter T for period of rotation. Because one rotation is what the period is, the distance traveled is still 2 pi r. So the equation looks identical except for small t and little t, or small t and big T. So same thing. When it comes to acceleration, the equation is a is equal to v squared over r. Now there's kind of a tedious proof to explain how you get that, and we don't need to go into it in depth. But very quickly, if I go a particular angle and use my velocities, my vf, and my vi, I can actually make a mathematical relationship where it's an equilateral triangle where the two v's are proportional to the a and the lengths of the sides are related to r. So if you look at it, you're basically saying a is equal to v squared over r. That's where it comes from. It's a pretty in-depth proof, but again, we don't need to worry about that. So we get a is equal to v squared over r. So it's related to change in velocity squared divided by the radius. Now, because we have those two equations, you can substitute this v into here and derive another equation, right? So we change that v to 2 pi r over t, square it, do the math, and you're left with this third equation. The advantage, of course, is this equation here does not have any velocity in it. You don't need to know that. Where this one here for the velocity, this acceleration, you don't need velocity, and that one you do. So they require different things. Now to get your final one, we've got velocity, the two acceleration equations. The last one is force. Now force is simply F is equal to mass times acceleration. We've got two different accelerations, so simply if you multiply mass by those two different acceleration equations, you get force. So we take the first one here, a is equal to v squared over r, so it's mv squared over r. Done. The next one is here. So a is equal to 4 pi squared over r t squared. Mass. You could leave mass on the outside, or again, if you just multiply it through, it looks like that. Right? And there we have our four equations, or sorry, 5. One for velocity, 2 for acceleration, and 2 for force. Now what you actually choose to use is up to you, because basically if we go back to here, from these two equations you can solve for velocities and accelerations, and from there you can basically multiply by mass. So you can actually use those two equations there, and F is equal to ma. Those are your three basic fundamental equations, and that's what all the other ones are derived from. So you solve for velocity here, solve for acceleration here, and then solve for force there. So what you actually do, up to you, but that's how you work with the 5 equations.